Greetings, beautiful people. Today, let's dive into the fascinating world of number systems, the unsung heroes of mathematics. You might think numbers are just digits on a page, but trust me, they have personalities, secrets, and even superpowers. Let's dive in. First off, we have natural numbers. Often denoted with the letter N. I personally refer to them as original gangsters of counting. They are the numbers you use when you are counting mangoes, oranges, or the number of times your lecturer will say, oh, this should be in the exams, and definitely to be in the exams. So it starts from 1, 2, 3, 4, 5, 6, and so on. Alright. Secondly, you realize that where is 0, 0 cannot be found. There comes whole numbers. Whole numbers decide to bring 0 along, so whole numbers starts from 0, 1, 2, 3, 4, 5, 6, 7 in that order. The reason why this is very helpful is that the addition of 0 in mathematics brought a lot of breathing space. So example, if I ask you, if I perform the operation of 3 minus 3, imagine that we don't have 0 in existence. What value are you going to get? So when 0 came, it means that when you perform an operation and the result is 0, then you can accept it as a number. Alright, let's get back to what you were doing. Then another thing is we have integers. You realize that in life sometimes things go downhill, so we also have to reflect that in mathematics. So let's assume that we have whole numbers from 0, 1, 2, 3, 4, 5, 6, 7, and so on. When life goes downhill, we need to also represent that in mathematics. So we have -1, -2, -3, and so on in that order. Now with integers, we can expand them into 3. So we can speak of positive integers, negative integers. Guess what is in the middle? 0. So with positive numbers, we always write them in this way, so it can be either 2 or +2. Now without a sign, it is still a positive number. You don't even need to denote the sign, but if the sign is there, it doesn't change the value of the number. But with negatives, you always need to have a sign in front of the number. So -2 should be there and -4. What about 0? 0 does not need any sign. Even with signs, it doesn't change the value of the number. I call it a neutral number, or the starting point. So if I'm starting from 0 and I move in this direction, I'll have my positive integers. And what about if I decide to move in this direction? I'll have my negative integers. Alright, now you realize that between 1 and 2 there are a lot of numbers. Between 2 and 3 there are a lot of numbers there. However, if we decide to pick any of these numbers and express it as a fraction, that leads us to a number that is called a rational number. With rational numbers, it can be expressed as a fraction or a ratio of 2 integers. So when you pick any of these integers, so if I pick a over b, or a is to b, since it's a ratio, we can express it as a fraction. So it means that it has to be these numbers, a or b, has to be an integer. Take note, it has to be an integer. So pick any integer. Let's pick 4 and 3. We can express 4 and 3 as 4 over 3 or 3 over 4. Now these numbers are what we call rational numbers. It has some unique characteristics. The first one is that when these numbers are expressed in a form of a decimal, 1, it's either terminate in the sense that if I have 1 over 2 and I want to express this as a decimal, this will be 0.5. It has an end, it terminates, it doesn't go on forever, right? The second one is that if it doesn't terminate, it will reoccur, but this time it will be a pattern. Example, if I have 1 over 3 and I want to write this as a decimal, 1 over 3 will not end, it will reoccur. So we have 0.3333 recurring, so the 3 is appearing continuously. When this happens, then you can say that if it terminates, if it's reoccur, if the number is reoccurring, then you can describe the number as a rational number. However, if it doesn't follow any of these patterns, it leads us to another type of number, which is known as irrational number. Irrational number. With irrational number, an example I can give is root 2 or the beautiful pie. So with these numbers, the property is that with irrational numbers, they will never play nice and become fractions. Their decimals go on forever without repeating. They go on for what? They go on forever without repeating. So you realize that when you convert root 2 to a decimal, it will go on forever and it will not repeat. It will keep changing. It will keep changing and changing and changing and changing. Right, so let's see if I enter the square root of 2. So the square root of 2, you see that it is not repeating and goes on forever. So we can continue until the end of time. So these numbers, they will never play nice. You can't predict them. They are what we call irrational numbers. And anytime you are picking a rational number and any of these is not an integer, A or B, they both should be an integer. If it's not an integer, then it becomes an irrational number. Thanks for joining me on this numerical adventure. Stay curious, stay calculating, and always keep the numbers in check. We'll meet again.